Hello, my name is Azucena Castorena, and today we will be talking about my drug that is called Wellbutrin. So I will now be going over the general description for Wellbutrin, like the brand name, genetic name, chemical name. Now there are several brand names for Wellbutrin, like there's Wellbutrin the 40th, there's Wellbutrin SR, there's for Febro the 40th, there's Zyban, and there's also Apolenzin. Now the brand name for Wellbutrin is bupropion. The chemical name is a little complicated to say, but I will try to pronounce it. It's RS negative 2 terbutylamino negative 1 dash 3 dash chlorphenyl propan negative 1 1. That's the best way I can say it. What is Wellbutrin? Well, Wellbutrin is an antidepressant medication that works in the brain. It's used for people who have diabetes, smoke cessation, and for those who have depression, so like major depressive disorder, which is MDD, or seasonal affective disorder, SAD. Any person who has any of the following are actually not allowed to take this medication. So if you're pregnant, have seizures, and if it's not prescribed from the doctor, you're not allowed to take this medication. Wellbutrin has shown to have significant interactions with other drugs, for instance, seizure disorders, Celexa, and Pentramine. Wellbutrin's common side effects are headaches, dry mouth, vomiting, nervousness, trouble sleeping, fast heartbeat, and weight loss. Something interesting about Wellbutrin is that it actually helps people to stop smoking. Now we have to draw our drugs line bond skeletal structure. So this is mine, has a hydrogen, and it also wants us to include the lone pairs. So in order to include lone pairs, there will be a pair under the nitrogen to make a total of 8, so 2, 4, 6, 8. We need 2 pairs in around oxygen to make it 8, 2, 4, 6, 8. And then there's only 1 pair, which is 2, so we need to add 3 pairs of lone pairs to make it all 2, 8. So 2, 4, 6, 8. So now we have to draw our expanded structural formula, and the direction says draw the expanded structure formula of your assigned molecule showing all atoms, all covalent bonds in the space below, include any lone pairs. So this is my progress in my Lewis structure, and this is the completed work that I got. So the green dots are the lone pairs, the red are the hydrogens, the blue is the carbons, the orange is the chloride, the pink is the nitrogen, and the black is the oxygen. VSEPR theory, molecular geometry predictions, directions. Show the expanded structure of your drug below. If your structure contains atoms other than C or H, check these other atoms and add lone pairs of electrons to each until the octet rule is satisfied for that atom. Use VSEPR theory to predict the molecular geometry around each central atom. Use a color-coded key, include a key for your colors to indicate the geometry around each central atom. So this is what I got for tetrahedral. It would be blue. The pink is trigonal planar. Now the green is the trigonal pyramidal, and I do not have a bent or a linear. Molecular formula and molar mass calculations. The direction says write the molar formula of your molecule, calculate the molar mass of your drug to the hundredths place using the molar mass from the periodic table in your text. So what I did was I got the number of carbons, multiplied it by the atomic weight, and that's what I did for hydrogen, chloride, nitrogen, and oxygen. So I got the number of elements, times it by the atomic weight, and then whatever I got, I added them all together, and I ended up with 239.746. Hydrogen bonding with water exercise. The direction says illustrate all the ways that the following molecule could form hydrogen bonds with water, either as a hydrogen donor or as a target receiver of hydrogen bonds from water. Do this by drawing the bent water molecules as necessary and representing hydrogen bonds between water and the drug using dashed red lines. Be sure that it is exactly clear which atoms on each molecule are involved in the hydrogen bonds. So what I got for this was I got 6 total hydrogen bonds. I got 3 hydrogen bond acceptors and 3 hydrogen bond donors. Hydrogen bonding with water, like the last page that I explained, it's the same thing. The only difference is that it's my drug. So for my drug, I got 3 total hydrogen bonds. I only got 2 hydrogen bonds acceptors and 1 hydrogen bond donor. Polarity and solubility predictions. So I construct your molecule below. Circle or highlight all the polar portions of your molecule. Make a reasonable prediction about whether your molecule will be soluble in water or not, and explain your reasoning. If the molecule seems to be borderline in polarity, making it difficult to predict solubility, explain your reasoning and the difficulty involved. Find a source, Merck Index, PDR, etc. that discusses in the water solubility of your drug. Compare the prediction and the information you find on the water solubility of your drug and comment on any discrepancies. So I got 3 total polar portions. I got 5 polarities, and my drug is actually soluble in water because it's hydrochloride powder, which is white and it's crystalline. For the solution calculation, the professor helped us write out the equation. So all we had to do was plug in the mole of our drug, and I got 2.76 times 10 to the second power grams, carbon 13, hydrogen 18, chloride, nitrogen, and oxygen. And then for question 2, I got 60 milligrams.